Happy Sunday. This is PFG.Live, the podcast dedicated to the writings of internet philosopher, Hey Man, Why Didn't Ya? Welcome aboard. We got a full house over in Discord and a bunch of people checking in on the YouTubes. Let's see who we got here. We got, a lot of people. Let's see. Evils is checking in from Ghent, where it is 20.7 degrees under his desk. Emmanuel is checking in 3 degrees science with 75% relative humidity in Zurich, Switzerland. Josh in the Win of Peg in the Canada, the Mitar CY Whiskey Golf. Thank you very much. Winds are 120 at 20, gusting 28, visibility 15 miles, overcast at 10,000, minus 19, dew point minus 23, and altimeter 3021. Welcome aboard. It says, in the remarks, it says pressure falling rapidly. Woo! Dale says it's a balmy minus 8 science, 17 degrees Frankenstein, and cloudy with a touch of snow, turning into freezing rain this evening and tomorrow in Northwest Hoth. Warren Jones in Sutton, New Hampshire, my neighbor to the north, says it is mostly sunny, 20 degrees Fahrenheit, which is a little nippy, winds calm and mostly positive. Arstead, chilly but sunny in Peoria, Illinois. Nick likes tools, and does he ever? 47 degrees Frankenstein in Louisiana. That's balmy. Ted in Eustis, Florida, just as I said, balmy. At Kilo Lima Echo Echo says winds are 270 at 6 knots, visibility 10 miles, few clouds at 3100, temperature 24, dew point 18, altimeter 3005. Remarks, playing with time travel today, GPS, DO, and NTP everywhere, vortices possible. We will watch for the time vortices. Bootstrap Garage, Calvin says in Waterloo, Ontario, home of the aperiodic monotile. From Charlie Yankee Kilo Foxtrot, winds are 340 at 7 knots, visibility 9 miles, clear minus 10, dew point minus 17, altimeter 3016. Who else is with us today? Carl Tauber, my neighbor to the north, says it's 32 degrees and snowy in Rhode Island. Yes, it is. We stopped snowing. Right now, here in Windham, New Hampshire, it's 30 degrees, 82% relative humidity. The snow stopped, and we had some little puffy accumulation. Manchester Airport reports winds are 340 at 15 knots, half mile visibility. Runway 35 visual range of greater than 6,000 feet. Light snow broken at 1,300, overcast 4,500, temperature minus 2, dew point minus 5, altimeter 2984. CS Weldfab, thank you very much. 27 and sunny in East Tennessee. Welcome aboard, sir. I can't pronounce your name, but Oscar. Oh, hello, Oscar. Minus 1 degree science in South Finland. Welcome. DS Fretch. Did I get that right? Westchester, Pennsylvania. You've been here before, where it's minus 6.5 degrees, snowfall, cloudy, northwest 17 miles an hour, 22 degrees, 52% relative humidity, 60 degrees, and 22.8% in the bamboo. You need some warmth in there, buddy. Thank you for checking in. Welcome aboard, everyone. We have a little bit of housekeeping and then a great show for you today. We're going to have a lot of fun. Carol checked in at plus 3 Celsius, 93% relative humidity in Vilnius, Lithuania. Long-time listener, first-time writer. Welcome. You are always welcome here. So, we're going to have a good time. Paul Morley reports Dallas is 38 degrees Fahrenheit and there is panic in the streets. Let's see. Today, we're going long. So usually we try to keep it snappy to 1 hour. I promise you today, we are absolutely going long. So as you know, we have Tom Lipton and Robin Renzetti. We're going to be executing the problem process. In the show, we call Two Guys and a Pencil. And get yourself something to drink, sit comfortably, and join us. Dave G says in Northwest Ohio, it's 17 degrees and 57% humidity. Welcome aboard, sir. Let's see. So we got that. We're going long. I wanted to tell you, one of our guys, and I didn't get permission to tell the details of the story, but I asked him, so I'm going to be more general. He works for a research university, and he was so inspired by the last Two Guys in a Pencil, where we discussed something that was very much like Mr. Saunders' puck chuck, that they are now designing robotic arm attachments around the puck chuck. And that's really kind of cool. So that was nice feedback with respect to the last time we did this. So a quick story. Oh, Bill Olney is here. Hi, Bill. Bill says in Rome, New York, home of the Air Force Research Labs, it's 28 degrees and snowy. Evils reminds me to tell people that they can submit more problems for the next one. So if you go to pfg.gg/links, you'll see a great big button that says submit a problem for the problem process, and you can submit a problem for next time. And if we choose yours, you win a Cupid doll. So my magnificent wife tells me that she's hearing this bizarre noise in the house. And I go downstairs, and right at the bottom of the stairs on the first floor, where we generally take our shoes off before we go upstairs, there was this sound. And it was like bup, 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 and very, very subtle, but there it was. And if you moved around, if you walked 5 feet away or 6 feet away, you couldn't hear it. It was just in this little area where you could hear this bup, 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 bup. And I'm standing there going, what the heck? And I actually was able to record it. And now we're trying to figure out where this sound is coming from. We're pretty sure our house is not haunted. So I turn off the refrigerator. Do you hear it now? Yes. Turn the refrigerator back on. Go downstairs to the air compressor. Listen to the air compressor. Maybe the little pump in there is doing its thing. Nothing. I keep listening. Finally, and this is spread out over a couple of days, finally I look at where the sound is maximum, and I look up, I look at the ceiling, and I walk up the stairs, and I go to where the area right above the sound. And guess what I found? DBX says, a pizza rat eating dinner? No, it wasn't that. Any other guesses? What was shocking to me is that it was so hard to localize. A teenager? Possible. So Josh is closest. In Jared's room, there was a fan. One of these weird looking fans that are kind of tall and cylindrical. And it was on. And I said, I wonder. And it had this big round base. It kind of tapered to this round base. And it's sitting on carpeting. So I turn it off and I go downstairs. I put my head in the magic spot. Gone. Go back upstairs, turn the fan on, come back downstairs. It's back. I'm like, okay, I think I got it. So last night we do a blind experiment. My wife comes over. I said, go to the spot. This was now a known deal. Go to the spot and listen for the sound. And she goes over there. She goes, I hear it. I said, okay, go to your office. I will call you back when I've done something. So I run upstairs. I turn the thing off. I run back downstairs. Don't indicate what I've done. I said, come out. Anyway, long story short, we went through 2 cycles of this. And we had 100% correlation, and then I told her about it. So what this was this circular fan, okay, that, I did dismiss the null hypothesis, Evils. The second time I told her to go check again, I didn't do anything, okay? I didn't change anything, And she caught that. She said there was no change. So it's a circular cylindrical fan, right? And it's running. And why are we hearing anybody guess what is the cause of hearing that sound from this wonderful circular fan running on a motor? You guys are absolutely going to get it on the first shot. Oscillator stuck, Paul says. Wobble, Evil says. DBX has a guess here. Lack of flatness of the base. I don't know. It was on, the carpet takes care of that. I'll give you guys a couple more. Insanity. So my first guess was insanity. I thought I was losing my mind. Yeah, so Evil's comes closest. It was out of balance. The stupid thing's out of balance. And the thing is going around and it's out of balance, so it's doing this wobulation. But it was so subtle that if you put your hand on the fan, you couldn't feel it. But if you go downstairs, you could feel the whole house. It's transmitting through the house. And that was the result of an out of balance condition. Turn on the little ad annunciator here. If your grinding wheel is out of balance, you're going to get the same problem. And it's going to show up in your work. This was so subtle, it was unbelievable. So I would encourage you to please balance all the things. And in order to do that, you might want to get yourself a model number BS8 from Kinetic Precision to balance your grinding wheels. It's not rocket science, but when I designed the BS8, it was to come up with a low-cost solution that somebody could buy and balance grinding wheels. Now, if you go to pfg.gg/BAL for balance, you will get to the product information page. Now, it is set up for the taper, the kind of the most common taper, which is used by the Sopco hubs on lots and lots of small grinders. So read the product information and go to town. Now, if you buy one, you get a 10% discount if you add a B200 balancing ring. And as of today, and this is for from today through January 10th, there is going to be a discount on additional balancing rings. Let's see if I can find it. Hang on. Hang in there. I can't find it. Is that it? No. I thought I grabbed it for you guys, but I didn't. So there's an additional discount on balancing rings. The discount is get a free balancing ring with the purchase of a balancing stand. So if you buy a balancing stand, you get a 10% discount if you buy a ring. And if you enter the special code, you will get, I'm looking for my code. You will get a additional free ring. And it's let me get the code for you. You'd think I was prepared here, but I really wasn't. Let's see. I thought I printed it out. Please stand by. Your call is important to us. There it is. Discount. Yeah. So if you use the code RING2026, 2026, RING2026, you will get a free balancing ring with your balancing stand, and you still get the 10% discount if you want a second balancing ring. So there you go. Check it out. Get balanced and stop that little. Okay, moving on. Yeah, I think we're ready to go. So first of all, I'd like to welcome the soon-to-be unmuted gentleman. Please welcome Mr. Robin Renzetti. Robin, you could unmute. There you go. How are you? Welcome.
Excellent.
What's the weather out there?
We got 3.5 inches of snow.
You did. You might even have more than me. And also, welcome, Mr. Tom Lipton. Tom.
Greetings.
Good morning. How are you?
I'm well, thank you.
And how much snow did you get?
None. 64 degrees currently.
That sounds like it's California.
Yeah.
Or something.
It's quite nice.
So today we're going to be doing Two Guys and a Pencil, the problem process number 2. We had so much fun doing number 1 that we had to come back and do number 2. So that's where we're going. I'm about to read you the problem, but first let me just catch up on some folks. Some imbalanced comments in the chat. Mr. WR Rocket joins us from Papa Alpha Delta, Quebec, which, if you don't know, is Kodiak Island in the great state of Alaska, where the winds are 320 at 22, gusting 32 knots. Visibility 10 miles, clear, temperature -4, dew point -15. Remarks: chance of bears. I can't completely decode that, but I would go lock myself in my house if I were you. Welcome aboard. Okay, so we're ready to go. We have about 30 people watching, and not all of them are admitting to it. Gentlemen, start your pencils. The topic is chainmail. So many people, despite the fact that they are no longer living in medieval times, wear chainmail to protect themselves against crazy people like us. And the chainmail is composed of rings. And people who make chainmail, who are still exist, have to make the rings a certain size and out of a certain alloy, and they have to meet in a certain way. The other problem with chainmail is that they have to make a lot of them. So a typical chainmail vest, for example, is a huge commitment to the artisan that's going to be making it. So one of the members of our community, Evils, he makes chainmail, and he said, we've been talking for months about chainmail, and he submitted this as one of the problems, and we've chosen this as the problem to solve. So I'm going to read from some notes that we got about this problem. In making chainmail, open parentheses, thousands of rings, I coil piano wire around a mandrel. The wire is generally less than or equal to 2 millimeters, and the mandrel is generally less than or equal to 10 millimeters. I then cut rings off of that coil and weld them closed. I am looking for ways to improve circularity of the welded rings, time spent manually adding preload, and repeatability / consistency of output. To achieve circularity after welding, I need a bit of extra material, so I need a bit of overlap in the cut. And to get a clean weld, I want either a clean 90-degree shear or a 45-degree X from a diagonal cutter. TBD, he says. The welding also requires a bit of preloading force on the joint, and overlap supplies this. The exact amount of overlap should be adjustable and repeatable, and for other applications, leaving a specific gap may be desired, such as round retaining rings. Time per ring is an important factor, so not having to fix radial offset or manually unload each ring from a tool after it is cut is highly relevant. Any approach that yields the same quality for the same time and labor that starts with bare wire is also acceptable, and any improvements, like not having to inspect and adjust each ring for radial offset or manually unloading the cut ring from the tool, are high priority secondary objectives. Currently, the time per ring is about 1.2 seconds to coil, 2.2 seconds to snip, 10 seconds to manually preload and close, but not to assemble nor weld. Gentlemen, this is the problem. Now, I will point out that we are aware that the same kind of rings that are used in chainmail are very similar to off-the-shelf retaining rings, but obviously there are different problems in this application, but it's applicable also in other industrial applications. So with that, do you guys have any questions for clarification?
What's the hardness of the piano wire?
Yeah, there you go. That was a good one.
What is
spring temper or something else?
Well, let's see if Evils, you could jump in on chat and just tell us if it's hard. It's so hard.
Actually, what alloy is it? Is it actually 1095, 1075? Is it
okay? So
any spring alloys at all?
So we'll get some comments from Evils in a second here, but I will point out that different alloys are desirable. Like sometimes people will make a chainmail out of brass or other stuff for how it looks. Evils says he's unsure. He said piano wire for something hard. In practice, it's work hardened 316L welding rod.
Okay, so that's not piano wire.
No. Yeah, right. That's not piano wire.
Piano wire to Robin and myself is either 1095 or 1075. It's oiled and it's typically very, very springy and hard. But welding rod's a little different. 316. It's actually pretty formable. So, what's the welding process? Are you TIG welding them or resistance welding?
It's TIG welding. He has the TIG welding with a controlled pulse, basically.
What's the amount of deformation required of the ring in the process of actually putting the rings together?
Elaborate the question.
Is this a standard like jewelry process would be you have a closed ring and you twist it this way so that the ends are like this so that you don't lose your contact, them touching. You twist it like this, you assemble and you twist back. Is that the methodology that they use to assemble these in the process of putting them together and making the mail?
So Evil says they open them about 2 times the diameter of the wire. You definitely need to open it enough to pass another ring into it. For usability, a bit over that is typical. So I think there's different methods. I don't think it matters to making chainmail, and you could correct me if I'm wrong, Evils, whether you do the twist opening or the pull opening. I think typically they're using a pull opening. He uses a twist. Okay.
That makes sense.
But I don't think that's part of the problem. I think if you said a better method is to not use the twist, which I'm not suggesting, that's what we're here for. As long as we're all wearing chainmail vests within the next 30 days, we're fine. No pull, it removes the preload. Okay, so he's agreeing to the twist. Any other questions?
Go ahead, Robin.
He's currently winding these on a mandrel, correct?
Yes.
Okay. First thing I would suggest is doing the method that I just did lately on some wire where I showed two ball bearings that are almost touching in an Aloris tool post. and then you're actually using it as a roll bender where you're putting a prescribed kink in the wire as it rolls around. And the V groove in the mandrel gives you a little traction, more traction than just flat diameter, and it drives the wire. The advantage here is that you can adjust that preload so you get exactly the diameter you want of the exiting material, and you basically have unlimited, as long as you can control your piece as it comes off the mandrel going away, saying you're doing it at a lathe, and the piece, the wires being wound or being bent, and the wire is exiting in a spiral where it's going around and coming out towards the tailstock. As long as you can control that, you can just go on forever. You're not limited by the length of a thing. But the main thing is you don't have the spring back that is never consistent with winding on a mandrel. You got to try one mandrel. Oh, it's too big. And with this, you literally can dial it and take a revolution and measure it and take a revolution and then get it tweaked in, and then it winds very consistently there. So that would be a suggestion just right off the bat, as a way to wind the wire as opposed to winding it on a mandrel.
So a couple of things jump out at me too. So he said 316 welding wire, and TIG welding. So what that would mean to me is this person is winding them out of 36-inch or 1 meter length sticks of filler rod, which would be pretty typical. And so hardness consistency batch to batch. So if you used a mandrel or a dial-in process like what Robin is suggesting, there might be some adjustment between sticks of rods. So this wire is not coming off of a large coil. So that would be one thing to increase your consistency, is to come off of a large coil where you had a particular batch that you could get a lot of rings off of, right? Now,
Evil says that he's considering a MIG spool source, so it could turn into a MIG spool pretty easily.
That would probably be better, because then lot to lot, you'd have a lot more wire that was a consistent lot. You're not typically welding wire is not super controlled for mechanical properties. It's controlled for chemistry, but not for mechanical qualities so much, right? Now, a little history from me is in my younger years, I made a fair amount of chainmail, believe it or not.
I didn't know that.
And it was a thing. Some friends and I were doing, and there is some tricks to moving faster with the ring making. There's some tricks for moving faster for the weaving. Now, I didn't make any welded mail. All ours was just twisted and woven, right? But the method that we use to make lots and lots of rings. So a shirt would typically have, this is something that has short sleeves, over 10,000 rings in it, depending on the diameter. And there's an ID-OD ratio where the stuff is still flexible, but provides proper protection and all that. So, but we used to wind welding wire that we used to get from a welding school. And we wound it in the lathe on a little round mandrel. That was the easiest. And when the ID-OD relationship, you're yielding the wire considerably. So the spring back is fairly uniform, and it was pretty easy to dial in the size. From that, we would have these. They would look like extension springs when they came off the lathe. And we first started doing it, we snipped the coils apart, but that produces a joint that's not as aesthetically nice, in particular if you're not welding them. So what we did is we took those particular coils, and from a 36-inch length of welding wire, I think the coils were, I don't know, about 2 inches long, something like that, when they were done. We put them on a mandrel, a second mandrel, and used a portable bandsaw to slice through the entire coil vertically and produce a straight cut. And then when you're weaving them, you twist them sideways, and then when you close that gap, you preload your wrists a little bit and twist it back into place, and the ends of the cut meet up quite nicely at that point. And from that, you could TIG weld them pretty easily, I think. So, so we made a lot of rings that way. And now welding them, that's a whole nother complication. When you're making the rings, you only need, for every 5 rings, you only need 1 open ring. So you can weld the rings into rings, and then you use a 5th ring at the center to join 4 rings together to make a little piece. It's a little flag, and then that flag gets joined with other flags. So every 5th ring needs to be open, approximately, right? So you can weld separately. You don't have to weld so many in the shirt. That's one of the other things too. How am I doing so far, Evil?
He said about half can be.
Oh, look, there's
pre-closed.
a little picture of the coil. There it is.
Yeah. That's how they're doing it.
That's how it comes out. Yep. Yeah. So if I was going to make a lot of rings, I would want a coil of wire, and I would want to do something like what Robin's suggesting, where they're not wound on a mandrel, because that's just another step getting them off of the mandrel. So you could make coils that were of some optimal length, right, for the next operation, the cutting operation. And so I suppose, so the Portaband did pretty good. That blade's about, I think it's 0.35 thick, and with the set of the teeth, it's a little thicker. So it would cut a little bit of material out. So if you push those two together, if you really eyeball that, the ring was not perfectly circular, but you could squeeze it a little bit and make it more round. I don't know what the tolerance, I guess how I would state it, the tolerance of roundness for appearance that he's looking for. That would be another question. Are we doing, is this presentation grade or field grade mail that you're making?
I would assume that it could be either. He says it's jewelry grade, which I'm going to assume.
Jewelry grade. Okay, that would be presentation grade. So really nice looking stuff. So, yeah. Well, I don't know. I think I would. So winding them. So how would you wind them with an overlap so that you could spring them open so that they were preloaded? That gets a little trickier there, because now cutting them apart is from the coils is hard.
Robin, when you would, I was going to ask you about.
I actually put that link in the chat of that Instagram post.
Yep.
It might be. Can you play that and show it or not?
I think I don't know if that's a video.
Oh, yeah.
Is that a video? No.
It's an Instagram.
I can't play it right now. Sorry.
Okay. One of the things that's extremely important relative to spring making is if you start with a coil. Well, back up. In spring making, the very first step in that wire before it goes to the actual spring forming area is straightening. It has to be straight, at rest, no lean, bend, or anything in any direction. Because when it comes out to the area where the spring is actually formed, and I'm talking about spring making where they drive the wire with traction rollers and it runs into a shoe that forms the wire by forcing it into a curl, it has to be straight. Otherwise, all of those stresses in whatever direction you're in are plus or minus to the yielding you're trying to do to the wire, and you get all these irregularities. So if you're not going to straighten the wire beforehand, the other thing you need to do, which I found in that particular situation I was doing with that wire, was I had to very carefully take the wire and unwrap it without losing the direction that it was wound in into a much bigger circle that still maintained the same orientation of the wires, so that when I was winding the springs using the mandrel, the rotating mandrel and the lathe and the two rollers that actually bent it, that the direction and amount of curvature in the wire was consistent. So there I was just faking it out by not having to pre-straighten it, but just keeping the current set of the wire in this particular arc oriented exactly the same as it was being wound. So that's one advantage of using the straight TIG sticks, is that they are straight inherently.
Yeah, they're already straight, right?
Yeah, they're already straight.
Well, wire straighteners are pretty easy to build too.
Yep.
And typically you run them through a series of zigzag rollers, a couple of cycles through there, and you adjust them until they come out straight. The other, in spring making, not so much in ring making, I don't think, is to get the right spring rates. There's a tension factor that they apply to the wire, and initial tension for winding. And but this would be more applicable to winding on a mandrel as opposed to what I would call air bending, what Robin's describing, right? Where it's formed and without the internal support, right?
Yeah. Yeah, you're in the particular situation where I'm talking about there, when that springs, some people might not realize it, but tension springs aren't just wound straight. Like Tom said, there's a given amount of preload in them that they have a certain initial tension because they want to actually get closer together than they're capable of, meaning there's an inherent, grip between the layers. Yeah. And that in the particular thing can also be accomplished about the entrance angle of the wire into the rollers can influence it, because the bend then becomes not just a straight bend that's perfectly perpendicular to the rotation axis. It's canted, and that actually makes the wire want to roll into itself, but then it runs into its mate behind it, and that's where that preload can be generated. I think for the male, when you talked about having rings that were inherently wanted to close on their own, but then also wanting ones they had to open, you could possibly tweak that initial preload such that when you snip the ring, they line up. And that could be a test in your setup where you wind them, you have a certain amount of preload, and then you actually snip them. And I'm picturing an internal mandrel piece that fits inside the wound springs and has a full 180-degree contact of a die shoe that is supporting the bottom of the wire. And then external on top, you have the opposite, and you're literally shearing these off and just backing up, shear off, back up. But you've got a full round, two opposed. The die is going like this.
Oh, half moons or whatever.
Half moons, right? That are shearing it off. One, and the actual wire is supporting the pressure of the cutoff by resting on the inside of the other side of the wire. So the wire would be in a trough that's supporting the OD. This mandrel would be inside for however long your segments that you're winding. And then the upper piece would be, you set this up either in a press or whatever, so that the alignment of the two die pieces is good. You slide your piece on and then clunk, 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 and just keep sliding it off till the next one sat in the V, in the bottom V of the internal piece to enable you to cut them. Main thing being shearing them off basically as square as possible. They're still going to have some die deformation because you're not fine blanking these to get them to be.
No, but he's going to weld them too, so that's all going to disappear probably in the weld, right? So let's see.
That's just some ideas there.
So my assumption, he's winding these in a lathe. Would be my guess. And so, what could we do to set? So I like the idea of shearing them, right? And then you can shear them. And so if you wound a more open helix instead of a tight helix, then you could shear with an over. You'd have enough room for the tool and to provide the overlap that would give you your preload and a nice circular ring, right? So, I wonder if if he's preloading the ends together prior to welding, when he welds them, it probably comes together some, right? If there's preload on it, when he heats it to molten, it's going to jump together, kind of like welding a bandsaw blade, right? And on a commercial inductive welder.
I'm picturing with the pulse TIG that it only has to be close enough that when the ball starts to form, they wet to each other and not just retract away and never wet. So
Yeah,
I'm thinking
they never
that
meet, right?
Yeah, they've just got to be just close enough. They don't have to actually be tight. They don't even have to be like where they're pressing.
It's actually it's probably pretty delicate, actually, thinking about it. Because if it's preloaded, so say it has a high preload force and you hit it with a pulse TIG, right? You're going to get some bulge there too,
Yeah.
right?
Yeah, you're going to get a bulge. Yeah.
Yeah, you're going to.
And conversely,
So he probably doesn't want a
Yeah.
bulge, and he probably doesn't want it necked either, right?
Mhm.
So necking or bulging is probably not cool. And
But I think we need to clarify that when we're saying preload, I think I'm following you 100%. But there's two different kinds of preload we're talking about here. One is the preload of when you cut the ring. What is the condition of the ends? So obviously, if you saw through it, there's no preload.
Correct. Yeah, there's no
You have
preload.
to bend it to get it to come by. But the only problem with that is, in order for you to do that, you have to have these staggered such that they can go past each other because they're going to spring back, and then you can bring them back in alignment. But if you shear them, what I'm describing, where there's no material removed, and the rings are already in the circular preload aspect of it. The preload we're talking about, the gap,
right?
isn't zero.
Mhm.
The preload what we're talking about here is where the rings, when they're cut free, want to, because of the amount of torsional preload that's in the wire from winding on an angle, it comes back inherently to meet up at the end. So it's like this beforehand.
If you can get enough to get it to spring back a full diameter, right?
Yeah, full diameter. Then that would be perfect. If you sheared them off square, then you'd have the perfect scenario, and then you'd make them all that way, and you would manually open up the ones that you need to.
Right. Then they would just
do
come
the
together.
center of and then you'd rotate it back and normal jewelry procedure and go from there. Hey Tom, can I share my screen if I play that Instagram? Not that there's anything magic about this, but it might be a clearer picture for the ones that are watching what I'm talking about with the setup.
You should be able to, yeah. If you have it on.
I'm going to attempt that. If you're okay with that, Tom. I mean, with Spencer.
Yeah, as long as the director can keep up. Go ahead.
Okay, so I'm going to share my screen, and then I'm going to go to share screen. I think this is here we go, Instagram right there. Is that down here? Oh, I need to go to that screen so I can see what's going on there. There we are. Are you seeing that?
Yeah, we're seeing that.
Okay, so you see the two ball bearing rollers. There's the guide. That guide you would adjust axially back and forth for the angle that the wire comes into there. And you see the groove in the mandrel for traction. And then the amount of X position that you have. Matter of fact, I probably could just turn the audio on. So
that's the finish coils, right?
Yeah, there we go. Yes, and they are intentionally that big.
And what's the date? That's November. I can't quite read it. What's the date on your post?
I don't know. Oh, November 14th, it says there.
So November 14th in Robin's Instagram feed is the post.
It's at the very top. You'll see this. And there you can see the big circular bucket piece there. That's what I did to unwind the wire off of the tight spool as it came, but maintained its orientation. I didn't let the wire twist or do anything crazy.
That's the relaxed coil right there?
That's the relaxed coil. That's where it is without having any, that's the diameter it wants to be roughly. And then that allowed me to keep that orientation going through the rollers proper. You can see that if you look down the rings that are on the chuck there that are all wonky compared to the ones that are stacked up, all those wonky ones was before I was controlling all those things directly. But then you can see once I got that lined up and consistent, it just laid down beautifully. But you'd go berserk trying to wind on a mandrel and get a controlled diameter with wire. What was the wire thin.
Here? What was the wire in this case?
This is tempered music wire.
Okay. So super springy.
Yep, super springy. And it's like, this is a 26 diameter wide, 26 thousandths of an inch music wire. But that gives
the stuff that'll poke right through your finger without even trying.
Yeah, that's it. Okay, I'm going to unshare here. Come back and unshare here.
That's pretty cool. Now, the diameter, the wire diameter to ring diameter is significantly different on that example. So there's some other forces involved. Yes.
So for chainmail, there's the idea is to end up with a flexible mail that's literally like cloth, right, almost, and has small gaps through it that little pokey knife type things don't go through. But still maintains its flexibility. So it's pretty severe forming, actually, diameter OD/ID ratio, right? So if he's, what did he say, 2 millimeter wire, 80 thousandths wire? That's pretty small wire, actually. So
and 10 millimeter ID, I think.
10 millimeter ID. Well, was that the 10 millimeter mandrel, right? So
less than or equal to 10 millimeter mandrel, less than or equal to 2 millimeter wire.
Okay. So what was the finished ring size?
Yeah, what did that come out? ID/OD.
Evils, just give us the ring, desired finished ring target.
So the stuff we did was 332 welding rod, which is about 2.4 millimeter diameter wire, and we were winding around a mandrel that was approximately 3/8, something like that, and it had a little bit of spring back, 10% or something like that would be my guess. It's quite a while ago now.
So Evil says a 9 millimeter OD with 1.2 millimeter wire and 6.6 millimeter ID, typical. And that's what he's doing right now.
9 millimeter. Well, that's a pretty small ring. Jeez.
Yeah.
So building something That's
one advantage of the method I showed there. I had a piece sticking way out of the chuck because the wire was so small. But one advantage of the method there with the rollers is that you can have a very, very short amount of mandrel. You literally only need enough for the wire and a little bit of overhang of the bearing that you're using to press on it, so that you could, let's say you needed a 5 millimeter pin with a groove in it in order to bend it far enough for it to come back, stay at 6.6 millimeter ID. The fact that you're chucked up so close to the actual working area, you could go, extremely small in this case, because almost nothing needs to stick out of the chuck, because the wire can come down in at, you saw at the collet side, but feed off to the tailstock side.
Mm-hmm.
So you can be real tight. So I think you could still use that method very successfully here for forming the wire, even though that's relatively fat wire for the size of the ID.
Yeah, it is. I'm just thinking of the forces there too, against you have to be pretty close to this. Well, let's see, maybe not.
In theory, the wire, the groove could literally be only maybe this. Let's say the left-hand side of the groove could only be maybe 15 thousandths away from the chuck, and you could use the only issue here is that you need to use smaller and smaller rollers to be able to get them to wrap around.
Exactly.
And
You got to have,
get,
you have to
yeah,
you have to have a
yeah,
forming V, right?
yeah,
Or
yeah. It has to
envelope
wrap.
around the mandrel. That's what I'm thinking about. The
Yeah,
forces would be pretty high
yeah,
on those bearings or rollers or whatever,
yeah.
right? So, hmm. You'd have to try it. I don't have a good empirical sense at that scale, right? And um, the forces, right? I mean, little tiny ball bearings like that are not particular load masters, right?
Yeah.
And
But you
although
could use
you could use bigger
needle
ones, I
bearings.
suppose,
Yeah.
and just change their. Yeah, I guess I would build something that was
You could
adjustable.
use what do you call it? Machined outer race needle bearings. Let's say with a 1/4 inch ID, and since the outside's hardened, you could put those together. You'd hold the inner shaft in there for that size. Let's say they're 6 millimeter ID, even
Mm-hmm.
the actual bearings. That would still have a very small OD. You just make a block to put the two shafts in that act as the
Mm-hmm.
shafts for that, and the collet could actually keep them axially from running off. And then that you'd be pressing with a hardened surface there that probably has plenty enough depth of V to wrap around there.
Yeah, well, that's where a layout would. So yeah, the next step would be to make a layout of the of that geometry and sizes, right? And see
Yeah,
what you can fit in there and what makes sense. Uh, so let's see, center pin.
I'm gonna go over to SolidWorks while we're talking here, and I'm going to do just a rough model of the cutting tool that I'm talking about, the
Oh
shearing
yeah,
tool.
the shearing.
Because I'm not sure everybody's picturing what you and I are. Um,
Well, I don't know. I think I know what you're talking about, but I'm not gonna. All right,
Yeah, if
so
you could
what
whip
is
something up on SolidWorks,
well,
Robin, I think it'd be
that's
neat.
what I'm,
That'd be super
yeah, that's
neat.
what I'm doing right now.
Awesome.
so it's a 6 millimeter mandrel, roughly, right? So yeah, with wire that large, Robin, you might not have to be like right on top of the mandrel either. So
Right. Yeah, I think that's the
I think you
case.
could be off of the mandrel a little bit. My sense is so. So that would allow you to use larger rollers or um, let's see the orientation there. So you were coming in vertically on yours, right?
Yeah, that's irrelevant, but
Yeah.
well, it's not irrelevant when you have to have your rollers be actuated by your x-axis cross
On the
slide, or
slide, yeah, you're going to want
yeah,
those
yeah,
at the 12 and 6 position
yeah,
or the 10 and 7 or something like that, right? So
yeah.
We're not satisfied until you're not satisfied.
what? Yeah.
Just keeping it light.
Oh. Let me want to do here? Let's do.
What could possibly go wrong?
Goodbye.
You've tuned into the PFG Live. We're watching the Chainmail Grandmaster Tournament.
Sorry for the no visual on this, but I'd rather stumble around in SolidWorks secretly.
Don't worry, we're still watching.
Don't need an audience. Yeah, don't need an audience to watch me stumble around.
Surely you can't be serious.
Of course I'm serious.
I am serious. And don't call me Shirley.
Let's see, rotate. Well, here. I don't mind fumbling here, so what I'll do is so that there's some minor entertainment value. I'm going to share my screen, gentlemen, or folks, or whatever.
People of all ages.
Yeah. All right. So
Tell me
I'm
when
assuming that you can see in there, right?
Yeah, you're live. Your screen is live.
All right. So let's see here. Let's do this. Just so people can. These two circles represent the mandrel and the wire wound around the mandrel. Everybody following that?
So the 236 is the mandrel.
Yeah, that's the mandrel. And the 354 is the OD of the ring, right?
Okay.
So what do I want to do here? I want... a nice... yeah, that's not out of the question here. So let's move that.
Just a bit outside.
Okay. Rotate. Let's see if two of those fit in there. So this is the, yeah, okay, that's not bad. All right, so what we got here is you got your mandrel, and then you got your wire diameter, and then this might be a couple of ball bearings here. And these happen to be a 1/2 inch OD, right? Which is, that's a pretty substantial bearing, more than, and these are oriented 45 degrees to the mandrel. And so what we would do is the mandrel would be on the spindle center line, and these would be on the x-axis, so that we can control their position in relation to the mandrel. Right, I show them tangent right now. That's the you would probably not be that close. So that's totally doable geometry-wise, and those are sturdy enough bearings to do that. And then the wire would come in from this direction here.
Mr. Tim Beattie likens it to a knurling tool.
Yeah, kind of like a knurling setup, right? Clean this up a little bit, get rid of some of this stuff. Yeah, right?
It looks good.
So, yeah, you'd have to have a stubby little mandrel, though. diameter.
or
But
so,
I think that's okay. I think that's okay. And then you just have to introduce a helix into it so that it comes off of the mandrel out into airspace, right?
Temptor Scent says bring wire between rollers diagonally.
Diagonally.
I think if I'm reading it right, he's talking about inducing the helix.
Well, that would be in a different plane. You would introduce the helix in the plane that's directly into the screen, right? That's the helix direction. So that's pretty small stuff. Well, let's see. No, so what Robin's saying though is so outside of this mandrel, you can have your shearing element, right? So let's zoom in on that a little bit. So let's draw a line from the center of that. And what do we want here? So let's say we want the shear line to be on the center line, right? That's where I would put it, if possible. Let's set that. Let's say it's 100 thousandths thick just to make it durable. Ooh, that's pretty thick. But it doesn't really matter, does it? It doesn't really matter. That would. I'm gonna see what Robin comes up with here. So if this thing is
Dave G says feed the wire in perpendicular to the center line of the top roller and the mandrel for center line of the top roller and the mandrel for less initial load upon entry of the wire.
a little thinner there.
I'm reminded of a quote that appears often in the Kinetic Precision Discord. We do these things not because they are easy, but because we thought they would be easy.
So yeah, you're not gonna be. No, that's not gonna work. But you can't. So if this is the shearing element here, you can't have that come to a sharp corner like that. So
I've got it. If the shear tool done when
you do?
when we're done. Yeah.
Okay. Well,
Oh,
I'm sort of doing one here de facto or just to think about it. So let's see. Let's trim that real quick. Get rid of that. Get rid of that. So that would be your shear tool there, and this is rotated 90 degrees. So that's this rotated 90 degrees. All right, let's see what Robin's got here. Let me get out of here. Come back. And not shear. Go ahead, Robin.
You saying the SolidWorks screen?
Yeah, but mine is tiny, so let me click on that.
Yep, you're up.
Yep.
Okay, so this is the. I'm going to hide.
Oh yeah.
This.
Okay.
I'm going to hide
I like
this
that.
body here. Okay, this is the inner piece, and this diameter to the left is the ID of the wound spring, slip fit, and then the radius of the groove that's in that is tangent to that at the bottom, and it's the same size as the wire. And then the punch piece obviously held in place rigidly to be able to shear across here. And ideally, this would probably be also curved. So instead of this being a straight cut through, we would wrap it around, not necessarily at the OD, but something that gave a little more support to deform the wire less, hitting on a little bit larger area.
Right. So it doesn't bend that one end, right? Yeah.
Right. Yeah. And I'll turn this back on and I'll go to section mode here. And so you can see here, this gap at the bottom here between this outer piece at the bottom is so that the loads of pressing down and shearing this are helped by the wire touching OD and ID in this outer cradle that cradles the wire for 180 degrees.
So this transfers the load across or whatever?
Right. Yeah, across there so that you're not expecting this pin. This pin can be longer now so that a longer piece can go in here. And you would just keep sliding off. Now, obviously, we would remove this lip here on the back for substantially.
Yeah, so the ring can come off easy, right?
Right. So it can just snap over and come into here and then get snapped off. And in theory, if we put enough preload, meaning the winding preload, such that the wire, when cut in this fashion, actually snaps in place or darn close to it, that would be pretty sweet if that could be made to happen.
Mm-hmm. So
there you go.
Yeah,
we have some questions coming in.
Okay.
Evils is asking, how is the punch piece held? How is the cut ring ejected? It needs a stop to set the overlap. How is this tool sharpened? He's getting ahead of us. Could you clarify? Go ahead.
All three pieces are held. Probably the bottom section would be a piece with a hole in it that the centerpiece with the notch in it inserts into. So you'd put a section of spring, whatever long it's practical. Let's say it's 2 inches. You would slide that in. This entire bottom piece would be that length. The bottom U-shaped 180-degree piece would be that shape, and it would actually be a full block with just that shape in it. That block would be rigidly mounted in a die set. The die set meaning something that physically holds whatever you're bolting to it, upper and lower, in alignment. The upper punch piece at the top would literally be placed in alignment in the punch press to set the gap. Well, not the gap, but the actual cutting clearance there, where those two meet together. And this is something where you aren't adjusting overlap on this. This is cutting rings with hopefully a perfect, reasonably perfect, zero gap and zero preload.
Cool. So you're popping rings off one at a time. You're not making a coil and cutting it later. This is going to wrap and cut. No.
This is working with a already wound section of wire, just like he showed in the picture.
Mm-hmm.
Yeah, it looks like an extension spring.
An extension spring is sliding over that pin on the back side.
Got it.
and coming up and snapping up over. I'm going to get rid of this. I'm going to isolate this piece if I can here. Isolate that, and I'm going to come back here and I'm going to take this and get rid of this so that you can see what this would probably look like. So we'll come convert and these. Oh, did I? Yeah, I'm on there.
Robin is working in SolidWorks. Ox Tools is working in.
There we go. Okay, now come here. Convert as. Oh, you kidding me? I am no way am I out of memory. You are delusional.
We'll get back to you. Meanwhile, what was the CAD software that you were using, Ox?
That was just AutoCAD there. I learned CAD on AutoCAD, so I'm pretty comfortable for quick initial layouts and sketches in that tool, and then sometimes I'll move from there into SolidWorks depending on what the what the problem is. But it's just a matter of training how I got trained. So. Yeah.
Oh, that's what I got to do. Sorry.
Oh, he's back.
He's back.
There we go. There we go. And so.
I keep thinking about those spring winding machines and how they shear how they shear the finished spring off in a lot of cases. If you're going to weld them, you might not need a curved shearing tool, but which is harder to make. And
there we go.
I wish I had a spring in front of me here. So I'm
looking
around my office.
Why is that still there? Oh, I know why. Duh. Anyhow, I'm not going to waste our time here. Basically that would be removed, and I'll isolate here. And so the only section that would be necessary there is right this here. This would still clear the spring all the way around here, and that's where it would cut. And that this would get pushed off when you push the next one on. It would push that one out of the groove, and lots of things would need to be tuned. Like this radius at the lip here would have to be adjusted, probably a little bit larger than it is now, because this is liable to pop out. These walls might need to be tapered out on an angle to give this a little more support from the lateral squash. So there's lots of die things that would need to be tuned to make that function, but that's the general idea.
Mm-hmm. So how is Evil? How are you cutting them now? What is your cutting method?
Evil says Knipex Cobalt, which is
okay. So he's cutting them with diagonal cutters or something like that. So
correct.
I think I have a pair of pliers that I've ground that basically accomplish the same setup that I'm talking about, using them for snipping.
It's amazing. I was having the same thought is, how would I modify a pair of regular pliers to do this, right?
I'm gonna go
And,
look through my drawer.
Yeah, exactly.
Okay.
And you could probably, if you found the right nippers, grind some of these features into some nippers to make a clean shear like that. Feed the coil into it though.
So
What do you got
this
there?
is, oh, there we go. These are regular wire cutters.
Yep.
They've
Okay.
just been trimmed off, but that's the action that you want. You want that full circle action.
Right.
There we go.
The
Like that.
enveloping, yeah. Mm-hmm.
Yeah. So as long as I can fit in the hole in the bottom, you would actually need to decrease these are meant, the cutting angle on these is designed for insulation.
Right.
A
You'd
version of
almost
this
need
with a
90 degrees almost, right?
well, yeah, well, at least a severely less,
Mhm.
more shallow angle could cut very nicely and accomplish the same thing, and not require a die set and a bunch of expensive stuff.
Right.
But
So
because I've done some. Go ahead.
do those strippers have, so some of those strippers have are clipping off machine screws, right? Where it's just two holes that are aligned in one condition, and then when you rotate the handles, the holes swipe across one another, right? And like
this
those,
stuff,
exactly.
right here. Yeah.
That would be a little tougher to get the coil into
Right.
that, right?
Yeah.
So,
But in theory, you could grind away everything that was over here down to where this could access. You could just grind away everything that wasn't functional for the one direction,
right.
where
And
you could get that into it.
That's fully enveloping there, which is really nice, right? So,
But you couldn't use it fully enveloping.
no, you couldn't. It'd have to be open
couldn't get it
on
on,
one
yeah.
side, yeah. So that would be something to look at there, is to modify some pliers to do this, to do a nice clean shearing thing, which will improve the welding and the fit up of the rings. And then winding the rings on I'm going to call it a 3-point roller, or in fabrication, we'd call that a ring roller, actually, where you have three rolls and one's stationary and two are adjustable in relation, or two are fixed and one is adjustable. You can go either way, right? But in this case, it would be one fixed and two adjustable rollers to form the wire, and getting the wire on in a long coil. That would be because then your winding's more efficient and consistent. So,
And you could mount this, in a fixture, air actuate the one end, foot pedal, so that you could just face this and take your ring and click, 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 just pop them on there and hit your foot pedal. And when you're talking 10,000, you don't want to be squeezing this thing 10,000 times to snip rings off.
Yeah,
I'm going to go get a piece of 16th weld wire and see what this does on it.
But when the first couple of times we made mail, we used some small bolt cutters that were clamped in the vise to snip apart the coils, which gave you a lot more leverage, and but it still produced that kind of V groove type cut in the wire, that you get from a diagonal cutter, right? Yeah, there you go. So those blue ones that are on the screen there, that picture, that's actually that's the deal right there, right? Because it's got the wire diameter in it, right? And as they close, they overlap, right? And so it supports the wire during the cut. So Robin, look at these. This is how these blue cutters here. So they got the radius in it, right?
Oh, okay, yeah.
So that type of blade, right?
Yep.
So I would build a heavy duty set of those, right? Which is pretty easy to do. Actually, I think Channel Lock sells. Let's look it up. Somebody look it up. Channel Lock hardwire cutters. Yeah, there you go. So Channel Lock made some special cutters for large diameter hard wire, I believe, and they have very, very short, stiff jaws. Let's see if I can find it.
Robin, did you just cut those?
Yep, I just got that. Yeah, that was amazingly clean.
Very nice and flat.
Yeah, nice and flat, and you can see the. See if I can.
Yep.
There, that's certainly weldable. Yeah, there's no actual smear or anything. That actually worked pretty good.
Very nice. So Josh posted a picture. Are those the channel locks, Josh?
I think those are cable cutters there, but it's close.
These are really nice. This would be a beautiful one for that. These are Japan. These are a heavy wire cutter, but this is nice and beefy. As far as the stoutness of this, you could grind the contour you want in the end of these, and these would be beautiful.
What's the make of that?
These are HIT Japan. Habitat for Humanity pickup there.
The scars.
Yeah, we have a super secret pipeline to Japan if we need to.
Yeah.
So there's a picture of the Knipex 95 range.
Yeah, those look pretty good.
I have to say, I was pretty.
I'm not a huge. Oh, go ahead.
I was just going to say I was pretty surprised to hear. We knew about Robin's experience with the larger rings, but I had no idea that you had a background in making chainmail.
Yeah, it's actually a funny story. The first I'll call it shirt of chainmail. This was when I was a teenager, basically, right? And we didn't have any money, so you're scrounging for material. So we found, or without incriminating myself, liberated some fence wire off of some chain link fence. So some of you that have put up chain link fence, there's a heavy wire that typically runs along the bottom. And in this case, it was, oh God, how big was that stuff? It was huge, right? It was.
I have a comment from a friend of mine that might be appropriate. He says, this is Bill. He says, making the rings is only part one of the problem. Invite them back for part two, connecting them all together, other than the painstaking double pliers method, LOL. Yeah. Also, give them a nice parting gift of Agway 14-gauge fence wire, the gold standard for DIY chainmail wire, back when I had to make 10,000 rings by hand.
So this, I had an old Prentice lathe, and we got this wire, and I want to say it wasn't 3/16, but it was not that far off of that, and we wound around a mandrel and then snipped them. Yeah, we snipped those apart. Anyway, the fun part was the shirt ended up weighing 60 pounds, and so the rings were. There was, I don't know, they were inch and something in diameter or something like that, right? But the whole thing weighed 60 pounds. And we went on a trip to visit some folks, and it was kind of a costume party kind of a situation. And so, of course, I wore my chainmail shirt, right? But they said, "Oh yeah, we're going to go out on a boat," and so the realization that this was a really dumb idea was when I was walking across the plank to get out on the boat, and looking down into Lake Tahoe, right, and while wearing a 60-pound chainmail shirt. And I'm like, oh man, I really don't want to fall off of this plank, right?
What could possibly go wrong?
What could go wrong with this, right? So yeah, it was kind of but you got to tough it out, right? It's like you can't wimp out at that point, right? If you're wearing chainmail, running away screaming is not an option, right? So,
Run away!
I want my mommy.
Yeah.
I want my mommy. I need my chainmail diapers changed, right?
Okay. There's an image I'm not going to be able to get out of my head very easily. Okay, can we get the art department working on a sticker of Tom in chainmail diapers? Thanks.
Chainmail diapers, yeah.
Oh god.
So okay, well there's some pretty good ideas there, right? So scalability, right? Sure, you can build a pretty fancy thing, but for some modest investment in some tooling here, you could probably have some pretty significant increases in your production, right? Your ring production, the ring production part at least. Weaving is that's a pretty complex problem, right? And there are some tactics in weaving that speed it up, and one is the 5-ring thing, which was funny because this is pre-internet, and so it took years to figure out that. I think we went to there used to be an organization called the SCA, Society for Creative Anachronism, I think was what it was, and we went to one of their events, and there was somebody making mail there, and they used this 5-ring and then connect those together, and our jaws hit the ground, because it was like, oh my God, we were doing it one at a time, right, and in rows, and which is just super tedious, right, and now they do make commercial mail, right? Wasn't Destin, Smarter Everyday guy, he's making some kind of barbecue scrubbers or whatever, and he's buying commercially made mail.
But those are tiny rings. Those are probably on the order of 5-ish millimeters.
Sure, yeah.
Yeah.
Right. This is a much more heavy duty, and I don't know if. Well, those are probably welded too, I would think. Because if you don't weld them, there's problems when you don't weld them, and if you get any rings that have a gap, then the gaps line up with one another, and then you get openings in the mail. It's all kinds of problems. So welded, and actually in the olden days they used to rivet them, and they would form a flat on each end of the wire, and they would overlap them, punch a hole through, and put a little tiny rivet in them. Because if you think about it, if somebody stabs you with mail, right, and the ends of the rings are not welded, right, that tool, that knife or sword or spear or whatever, wedges open that ring, right? So the mail is not effective then.
Would you say that would be the earliest example of junk mail?
Junk mail. Pun intended, huh? Yeah. Junk mail. Yeah. That's pre-spam, yes. I would agree.
So how are we going to achieve some time savings and cranking these suckers out?
Well, if you can power your shearing tool, right, and so that you're just stepping on a foot pedal, or you have a significant mechanical advantage, right, over a plier type thing, that'll certainly speed you up. Or like we did when, one saw cut produced, however many turns was on the mandrel there. So 2 inches, 40 rings or something like that. Right. with one saw cut, boom, and that was definitely faster than cutting them with a nippers or bolt cutters, right? So, I mean, with hobby operations like this, right, you're always balancing the making it more efficient, right, but not spending all your time making tooling to make the thing that you want to make, right? So, are you going to build a factory to build mail just so that you are more efficient? No. So what you're looking for in these cases is incremental improvements, right? So that you can be more efficient or use less of your time or energy producing the rings, right? And so you increment your way up to the factory. So
some of these hobbyists are pretty serious. You'd be
sure,
and they are not afraid of spending money. Carl Tauber in Rhode Island says butchers wear chainmail aprons to stop stabbing themselves.
Yeah. My dad used to be a big fisherman, so I bought him a couple of those their chainmail gloves for when he was doing fish filleting and stuff like that, right? They actually help kind of grab the fish, and they also protect you from errant knife blades and things like that. So yeah, I mean, incremental improvements in this process is to build a better winder, and then procure the wire on in larger quantities on a coil, right? Those would be so there's just less handling, right? So if you're handling individual 36-inch sticks, right, you got a lot of handling time, right?
And you have waste. Because the stick is going to have
you got some ends that you're dealing with, right? So you get some little ends. So, but if you can produce these coils that are, let's just say they're 300 they're a foot long, they're 300 millimeters long, right, of these coils, and now you got several hundred rings that you can handle once and cut apart, right, with your shearing fixture, right? So I think you would have some net savings in that, right? So, but yeah, I would probably modify some pliers and then put an air cylinder or some kind of actuator on them so that you could do a foot pedal or push button or something like that, and get a single cut, a cut and a retract, right? And
well, the shearing action that Robin just showed us was pretty impressive. It looked really good from that particular hand tool.
But that's also having a really excellent joint is key to the welding too, right? And it makes the welding easier, and it makes the welding go smoother. And I'm sure, I never tried welding any making chainmail, but I'm sure that every once in a while you blow one away or that it burns back, right? And now that ring is useless, and you got to extract it and put a fresh ring in there too, right? And do that. So having better joint fit up would certainly improve that part.
Robin?
I just realized that I was thinking that mistakenly that the act of cutting it gave you a perfect joint alignment, and that's not the case. Once you cut it, you still have to reorient the piece to cut again, which if in the way that the cutters I showed, the shear cutters, you could put either a trough, V-block, whatever, that kept the center line of your stack of or your length of wound spring, kept it centered with the cutter. And it could also have such that the height was such that it slides right over and is lined up with the jaws, such that the cut end, let me get my hands here where I can see, the cut end boy, this is really weird. the the cut end comes up and hits the blade, automatically aligning you for the next cut so that it is a full 360-degree cut. So I was missing that part when Evil said that, how are you adjusting because you can, cutting them with just any ordinary plier, you can cut them with a quarter of a rotation gap or a quarter of a rotation of preload. So that is something. But having that wall of the cutter that is the cut face, enabling you to just put it in and just putting a little torque on your stack of springs when you go in, that could give you that very consistent cut. So that would be some very simple things, just some guidance for the lineup of the springs so they line up with the tool, and that you just simply have to put it on, snip, let it drop, put it on, snip. But I guess one of the things could be that having with Tom mentioning that 4 out of the 5 can be welded right away, you could have a situation where you possibly take it from that position right there, and while have it in that zone, actually weld it. So something where you grab it, the ring comes off, it drops into thing where it actually forcibly forces the two halves to come together. It rotates the two halves to come together and line up. And then once it's in that position, it zaps it, drops it out. So that might be something very small to do the majority of them
if he's going to continue. If he's going to continue to TIG weld them, then another add-on would be a nice welding fixture, right? So when you cut these apart, typically they end up looking like a lock washer, right? Just a standard lock washer, right? And then you twist the ends into alignment, you use pliers and you twist them a little past, and then they come back to perfect alignment, right? But you could build that into a welding fixture, right? That took that helix out, right? For one, took the helix out, and actually, there you go. There's a picture, and preloaded them together a little bit for the welding operation, right? Kind of pushed them together, and if the welding fixture enveloped up close to the welding area enough, right, and would help the welding process too, right? Because you're just working on it. It acts like a heat sink, right, so that it doesn't melt back too. So on small diameter like that. But that's functionally what a chainmail ring looks like, right? Except it's a round cross section, and you twist those two ends, and so there's something else to study in YouTube search is how they make split lock washers like that, right? Because this is exactly what we're talking about. It's just a different cross section, right? So they're winding rectangular wire, or probably the same way that we're talking about. I don't think they're winding those on a mandrel. That would not make any sense at all. And then those are clearly sheared, though. So I wonder if
most of the spring machines I see, I don't know if you get a lot of them on Instagram, but I see quite a few spring winding machine demos on Instagram, and you see it squirting the wire out, and it just has different, I don't know what the technical term is for them.
Fingers or whatever.
Fingers that come up that interfere with the wire. So in this case here, they'd be squirting rectangular wire out. They'd have a finger there that forces it. It has to bend, and it curls it around. But then all of them have a shear tool that goes right across the face of where the stuff's exiting.
Exactly right.
And pops it right off. And so that's probably the way those are done. But the amount of right there, those are wound with no preload as would be considered for a tension spring. And we're thinking that if we can't, the entrance of the wire, when we talked about the roller setup, angling the entrance of that wire until when you cut them, this actually almost flattens out because it's got that much preload where it wants to come back and lay flat inherently.
D-helix, you mean?
Yeah, D-helix, because it's wound where it's pressing on itself that preload, the preload force that's the axial preload
Sure.
force on a tension spring. That
Yeah.
there's nothing saying that the aspect ratio of the ID to the wire size that you could get there no matter what you do, but you could probably get a good portion of the way there, meaning getting it to come, let's say, at least halfway back or whatever.
Right. So there's
In the
less aligning
process.
to do.
Yeah. Because if you just take them with that much helix and forcibly force those ends to be lined up and weld them, when you take it out and look at it, that helix wave will still be there. It still will be a potato chipped. It will be reasonably flat, but it'll still have the effects of the torsional strain that's in the or stress that's in.
When we wound and wove mail by hand, you would exaggerate the twisting motion of the alignment process, right, to take out some of that that wave that Robin's talking about, right? And you would take it beyond and then come back, right? And then the width of the pliers was important too, right? That you're grabbing a good section of the two sides, right? When you form them together, or when you twisted them, right?
Yeah.
And so to take out some of that waviness, otherwise the rings were not flat and they looked kind of funny. So yeah.
One of the things that I'm sure Tom will agree with this. This is a perfect scenario of where this problem. Tom and I can't fix this problem. And there's, I mean, yeah, we have a fair amount of experience in this type of stuff, but we can't fix this problem just mentally, not pursuing this with our hands and making little test things of an idea and proceeding with that. Both of us would say this, okay, we'll try it. And we would go build whatever it is in the simplest manner possible to try a concept and say, oh, okay, this works. We're going to pursue this further. Or no, that's crap. Doesn't work at all. And just instantly shift gears and just keep bang, 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 bang. Each problem, things that came to mind. And because we can make what we're thinking about on the fly and have some design background for ways to approach this problem, that's how this gets solved. Neither one of us is going to solve this just yakking about it. Put the two of us in the room, or either one of us in the room in our shops, and you would see the progression of, okay, try this, try that, try this, and just work our way through. Oh, this works, except this isn't going to hold up because the clearance angles are too steep. Make another one, and just on and on and on until you get it perfected to a point. Always thinking of the simplest, crudest way possible to test the idea, so that it takes the minimal amount of time. Once you say, no, this is it, then you can start refining it, making it last longer and all these things. But that's the real guts of this type of thing. Doing it with an engineering wall, on one side of the wall, and trying to pass concepts over to the machining side. Okay, try this, would take forever compared to, and Tom and I are not the only people who can do this. That there's tons of people who would do exactly the things I'm talking about. But that's how this kind of problem gets solved.
Yeah, the thing Robin's illustrating is actually like something that's missing in a lot of modern engineering departments, I would say, right? And that people will sit on their computers with some kind of modeling program, and they'll work on a problem like this for months, literally, and without trying anything. And then so it ends up being this kind of sunk cost fallacy problem, right? It's like, we've spent 6 months on the design of this. This is going to work, right? And and how many times have we seen that not actually occur, right? And the most effective prototyping is when you have an engineer that has somebody like Robin or myself at their disposal, right? Where they come out and they go, hey, I got to do this crazy thing, right? And I got to form rings. Okay, what size, right? And then so that begins the process, right? And I know from experience that we had talented machinists in our engineering job shop, and a lot of times it was quicker to try 3 things out in the shop than it was to sit at your computer and noodle over this problem that you thought you had, right? And that you could try 3 things out in the shop quicker than you could conceive of 3 new ideas, right? And so to me, that's an integral part of doing kind of conceptual design, right? Is you end up building some things. And a lot of times we would end up, well, we know how to do that. We'll do that with a servo motor. Okay, we'll do that with a such and such bearing, and we'll do this. And then you kind of get to a spot where you're like, wow, I don't know how to do that, right? And you might go, well, what's your best idea, right? Well, if I was going to try something, here's what I would try. I would try 3 little ball bearings on a thing and see if the wire formed the way I wanted it to form, right? And then you would go try those things and observe and react to and learn from that, that experience, right? And then modify your next. Then a lot of times it exposes a better pathway or identifies a dead path, a no-win kind of scenario, right? And but that is the best way to prototype this kind of stuff.
If I could point out that even in our humble podcast here, Robin still got a tool and made a cut and observed the cut. I mean, it was like we physically did something, and by we, of course, I mean Robin, as opposed to just talking about it. So we made progress physically, like immediately. And I think that's a great,
and I'm looking around my office here, and I got 3 spiral wound notebooks, and I'm looking at the coils on them, right? And so there's no substitute for putting your hands on stuff, and for people like us that that actually physically build things, right? And it's super difficult to solve problems like this just sitting in a computer. And people that actually do that work and are really good at it and have a what I would call a high success ratio, which is anything over 50%. I tip my hat to them, because that's actually very hard to do, right? It depends on, it depends what you're building too. If you're building something that's never been built before, or I think there's no way to get out of physically building stuff to test or try. Right.
We have a sticker in the collection which says P1 only has to last 15 minutes, and just get to P1.
Yeah. So one of my design heroes is Edwin Land of Polaroid, right? And one of his what axioms, or what I don't know quite what you would call it, right? Is there's always something in the room that you can use as an analog to help describe or illustrate your problem, right? Or a potential solution to your problem, right? So literally, like tape dispensers and notebook spines, whatever, right? He always felt that there, you can make a ball of tape and do things with it to further the process, right?
Yeah. So, I'm holding a clothespin which has a steel spring in the middle. I mean, like I didn't have to get out of my chair.
Spring, right.
Didn't have to get out of my chair to find a spring.
Right.
Is example. That preload question that we're talking about is, can you put enough axial spring rate preload in that tension spring that we're basically making, such that when you snip it, it closes up completely? Well, I already have the ball bearing thing sitting over there on the shelf that I can drop on the tool post. It's sitting in an Aloris holder. That's why you have like 120 Aloris holders, so that when you make one of those things, it's still there, ready to go.
Wasn't the number?
Right.
Excuse me, sir. Wasn't the number 116?
I was just getting ready to correct myself. 116.
We track this,
right.
Yeah. We have the.
Yeah.
You got 116, right? Yeah. They said it's 116.
Yep.
Okay.
116. Yep. And I believe he said, I think this is enough, right?
But when people, if you ask somebody,
that's exactly what he said.
A CNC machining center, and it's got 200 tool pockets, and the guy has 6 holders, and he keeps changing end mills between the holders for every job. You'd say, and he says, well, they're $150 a piece or $200 a piece.
Yeah.
And you'd be like, I don't care. Buy 50 of them. Buy 100. And
exactly.
These are what, $25, or less. Buy them on eBay for $12 a piece, $15 a piece. That is the cheapest efficiency known to man. It's just ridiculous to not have that. Now, you have to have a reason for that. I have a reason for having that many. I actually, make a living still doing this. It's obviously a hobbyist. There's no value in that for a hobbyist having that many. But anyhow, back to the topic. I could have gone over, got my thing. I could have put a piece of stock in the Harding, put a groove in it, roughly the size we want, take this 16th diameter wire, see what the wind difference was, snip it, and answer the question in probably 20 minutes.
Right.
And that's a perfect example of the progression that would keep going on that and, just go from there. And the other thing that helps is a long history of being fortunate enough to be asked to do this stuff for a living for a long period of time and having oodles and oodles of opportunities to try all these different things. And that builds a library of knowledge that makes this path get shorter and shorter and shorter to get from the beginning thought to the answer, is because there's so many similar things we've done that we know this happens, and pitfalls and structural things that we know that even though that works when you put the pieces together, you're going to exceed the elastic limit of that that piece of material. Those kind of things. Once you get that kind of stuff, that just shortens the whole thing. But like for example, Tom having experience in chainmail, myself having experience in making rings for mail for jewelry purposes for my wife. So that's why I had those pliers that I shaped into that thing, and understanding a little bit about them. So that having a history of working in that stuff helps immensely too.
Let's circle back to the customer here, okay, and ask the question: was this helpful? Did any new areas for improvement become apparent? And if anything, what would be the, let's see, how do I want to phrase that? Well, no, that's probably good enough. Let's get some feedback from the customer on was it helpful? Did the ideas that you didn't consider come out of this? What areas sound promising? What sounds too hard? I don't know.
He's typing.
He's typing?
He's typing.
Oh, he's not.
Hey, there's delays in these kind of systems. What can I tell you?
Okay. Can you work on that, please?
Yeah, we're working on that. We're going to have a whole team working on reducing the delays.
Yeah, a whole team.
Evil says they cost definitely useful. Didn't consider the option of adding that negative preload. Sounds like my idea of modifying a shear is worth exploring. I think we're all nodding our heads up and down. Mm-hmm. Robin's nodding his head up and down.
Yeah, the important part about that shear is the conforming shear elements that are distributing the load around the cut such that you don't deform it. If you just take a shear, straight shear, it's going to flatten it on two sides, it's going to swell, make it wider, and it's not going to be round at the cut. So that circular, at least a huge portion of that being a circular engagement with the wire is what made that cut so nicely and not misshape the ends of the wire. So you want to be thinking that that's a very important part of that shearing. Is the actual conforming blade.
One shop I worked at, we had one of those diacro rod parters, and it was called a parting tool, right? And what it was two ground plates that were ground flat that had holes in them, different size holes for the different size rods. And we used to shear a 1/4-inch rod in that. And then those two ground plates would just rotate on one another, right, and produce the shearing action. But I remember very distinctly that the cut surface from that was just absolutely beautiful, right? And it would you would hear the rod snick off, right, and then you would pull it out, and there was like zero distortion because we were shearing cold rolled rod, which was pretty much on size, right, and it fit the hole quite nicely. But the sheared end, it looked almost machined, right? So that's the illustrative example of fully enveloping around the wire, right? Now I don't think it's possible to do that when you're shearing off of a coil like that. You have to be able to produce an opening to get around the wire, but who's to say that opening can't separate the next coil a little bit as part of the shearing action, right? So it can spread the wire coil a little bit and get around it and get almost a full 360-degree contact, right? And to clip that off.
So are you describing the cutter has the almost semicircle in it, and then a little wedge action to kind of push the adjacent turns away and go in for the cut, or push the next door neighbor away.
Well, I'm just saying that the tips of that, can interact with a wire that it's not actually cutting, right? And just so that you get better contact in the area that you're cutting. I'm thinking out loud here. So
No, I don't want to share my screen. Wrong thing. Sorry.
No, you could just do it. You gonna hold something up?
Yeah, I can do it. There we go. I gotta.
That's PenCAD.
See what he's got there.
Come down.
Down a little bit.
Down.
A
little more.
In front of your face. Hide your face. Yeah, there you go.
I get that a lot.
So the little side angles on here.
Yeah, they support those corners. Yeah.
Yeah. So I'm pointing to the part of there. These are probably should be a little shallower than that, so that they can kind of just separate the wires without doing a lot of damage. But that would be and obviously I'm showing kind of a cross section where they meet. Because
that's where they meet, but they're going to go past one another. Right?
They're going to go completely past one another. But that's an example of what you would do. And this is something where you just take a Dremel tool and have some diamond tapered mandrels to do the holes, size them. That's something that with medium skills you could grind that up and give it a whack. And
pretty easily.
Pretty quick. Yeah.
Awesome. Well, does anybody in the audience have any questions? I think Evils is typing. We'll take some more questions. I think it's important to point out that we got to observe a lot of process here. I mean, this was not an obvious problem, and you guys attacked it from a bunch of interesting angles. And I think it's that process that's important to learn from.
So, but I would say that this is it was constrained in some way, because this is not necessarily how Robin and I would attack this problem. If we were sitting in the same room together in a shop, I'm sure we would have built something or put something into the vise or modified a pair of pliers or pulled some wire out or there would have been some physical action if we were in the shop environment, right? Right, we'd be bouncing between the computer, a scratch pad, and something in the shop, right?
Yeah.
To attack this a problem like this, right? And what does it actually take to form that wire, right? And what kind of edge do you get when you just shear it with this, right? And hey, do you have a chisel that we can grind a little mouse hole into, right, or whatever, and try that, right? So, yeah, I mean, potentially even a chisel. The wire was supported.
I would fire up. I would have the grinder fired up in about a microsecond.
Yeah.
Yeah, right. So,
Tom using the computer strictly to find the relationship of the small diameters we were talking about and how the rollers would contact, what size they could be. That's a perfect example of jump to the computer to get things can look on paper can look easy, but then when you put real numbers on them, sometimes you go, ooh, that's not going to work. But that's a good use of that. Get the idea first. Use the computer for doing the trig and everything where you can easily stretch things around, change numbers, very quickly experiment, see what's going on, and go from there. But you notice neither one of us started on the computer.
Yeah.
That was that's more just for filling in numbers and finding out, okay, what does this actually going to look like if we try to make this? Is that practical?
Yeah, a friend of mine worked for a company that they made these surgical tables, right? And surgical tables are actually pretty complicated. So depending on the type of surgery that they're doing, they have a lot of different adjustability features and features built into it to assist the surgeons, right? Well, anyway, he was designing some hinge. I think it was a hinge. I don't quite remember. It's quite a while ago. And he calls me and he says, hey, I'm looking for a bearing that's like 1/4 of an inch in diameter that'll take, a 2,000-pound load. And I'm like, whoa, what are you doing, right? And then he told me what he was doing. And I said, well, you're going to have to invent that bearing, I think, is one of your problems, right? And because nothing commercially available is going to do that, right? And so he had kind of worked himself into a corner, right? And starting from the outside and moving into the assembly, right? And it ended up with a space-constrained design where he had a high load that he had to deal with, right? So I don't remember how he solved it, but it wasn't with a small ball bearing. So
the laws of physics were not with him at the time.
No, but that's an example of if you have a conceptual idea, right, is at some point you really need to check some sizes, right? How big does that pin? How big can it be, right? Because usually there's some hard constraints, like we want this ring to have an ID of X, right? Well, X is your hard stop there, right? You have to work with that. So so at some point you have to relate it to some of the hard conditions of the design, right? And to see if you're actually in the world of reality, right? And space-wise or size-wise for available components or fasteners or whatever, right? So, by the way, I need a screw smaller than 000 to actually make this work, right? So
you need V-shaped molecules is what you need.
Yeah, right.
Well, I think let's see. I think we could bring this in for a landing. You guys have been awesome attacking this problem. I appreciate it. Hopefully next time we see you, you'll be wearing a chainmail vest, but not swimming. Because I
would caution and say we didn't solve it. We may have incrementally improved it. Okay?
Yes.
And solving is in the design world, I don't think you're ever quite there, right? Things change, and there's always typically room for improvement as you scale a particular thing, right? The conditions change. So yeah, I would say that maybe we incrementally improved it. So
is that your final statement, sir?
Sure.
Tom, thank you very much. Robin, would you like to make a closing argument?
What he said. What he said.
What he said. You guys are the best. Okay, I think it's appropriate to put the ribbons on this thing. Thank you very, very, very much. Spending 2 hours. 2 hours.
That was fun.
2
Robin,
hours?
yeah, that was 2 hours. And Tom,
Wow.
we appreciate you. Tom's YouTube channel is Ox Tools. Robin's YouTube channel is Rob Renz, and those will be in the description of the video. We will be heading over to the after party roundtable, and if Tom and Robin want to come hang with us for a little while after a brief break, if you know what I'm saying, you're welcome to join us. In the meantime, I will say thank you very much, guys. We'll see you over there. And just to wrap things up from a business point of view, I did find the information that I couldn't find before. There's the discount code for the BS8 balancing stand. Get one balancing ring free, and you still get the 10% discount on an additional balancing ring, which is the normal discount. So the special code is Ring 2026. And with that,
So what's the deal? Did you run too many of these, or what?
I slipped a digit when I sent it out to China, and they kidding. I'm
Inventory,
kidding.
Outgrowing the bin.
Yeah. No, we've got a fair number in stock. They don't fly out the door, but I make about 100 at a time, and hopefully improve the process every time.
That's a lot of flying.
It's yeah. But who wants your balancing wheel to go like that stupid fan? All right, guys. Thank you very much. We will see everybody in the after party roundtable, and I will remind you to get flat and stay flat, and we'll see you next time. Thanks, guys.
Thank you all. See you later.